Hello, this is Mr. Collier, and today we're looking at the chain rule. Okay, firstly we have a starter that is not related to the chain rule, but if you want to know more about chain rule, just skip this first example and go straight into it. So this starter is just a geometric sequence or series question. And we have the sum to infinity is 76. Recall the formula for sum to infinity of a geometric series is the first term divided by 1 minus the common ratio, where r has to be between 1 and negative 1. Okay, so we have the sum of the infinite sum is 76, so we have 76 equals a over 1 minus r. And if we have the common ratio as r cubed, we have the sum is 36. So let's set up another equation, and we'll solve these simultaneously. So we can solve for a, and we have a equals 76 times 1 minus r, and a equals 36 times 1 minus r cubed. And what we can do here is we can actually factorize this one right here. 36, now this is 1 minus r cubed, factorize it to 1 minus r times r squared plus r plus 1. Okay, so this is going to be a very important type of factorizing that we're going to do later with complex numbers, but in general, if you have 1 minus r to the n, it factorizes to 1 minus r times r to the power of n minus 1, or let me write this way, 1 plus r squared plus dot 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 dot, all the way up to r to the power of n minus 1. Okay, so this always holds if you got 1 minus a number to the power of n, or a variable to the power of n. Okay, so now we have that solved and factorized, and this is also equal to a. Then we can set these equal to each other. 76 times 1 minus r equals this. We know that r does not equal 1. It can't equal 1 if there's an infinite sum, so we can divide both sides by 1 minus r. Okay. So we have 76 equals 36 times r squared plus r plus 1, since r doesn't equal 1. So it's a very important note that, because we can't normally just cross these out. We can only cross them out if we know that r is not equal to 1. To simplify this a bit, we could divide by 4. If we divide by 4, we get 19 equals 9 times r squared plus r plus 1. So 19 equals 9r squared plus 9r plus 9. 0 equals 9r squared plus 9r minus 10. And then we can factorize this. We need two numbers that multiply to give you negative 90, add to give you 9. Those numbers are 15 and negative 6. So this is 0 equals 9r squared plus 15r minus 6r minus 10. 0 equals 3r times 3r plus 5 minus 2 times 3r plus 5. So we have 3r minus 2 and 3r plus 5. So r equals 2/3. R equals negative 5 over 3. And recall r has to be bigger than negative 1, so that one's not possible. So the only r value possible is 2/3. Okay, now let's get into chain rule. And we're going to have a reminder of composite functions first. So remember, a composite function, f of g of x is, in this case, it's 2x plus 1 squared. So this is a composition of functions. The 2x plus 1 is inside the function x squared. Okay, so you need to recognize that when we're doing some derivatives. Like, for example, this derivative here. This is like, the h of x here is like x squared plus 3 to the power of half. Okay? And k of x is like 2 times 3x plus 1. Right? Actually, this is 3x plus 1 to the power of negative 1. All right, we're going to look at some derivatives now. We're going to do this two ways. We're going to use the chain rule, and we're going to expand it and find the derivative normally. So the chain rule says, and there's another way to write the chain rule, if you have a function inside of a function, then you can get the derivative of that. And the chain rule says you have to multiply by the derivative of what's inside the brackets, basically. Okay, so this is the chain rule. So we're going to do this by expanding and by chain rule and compare the answers. So expanding and chain rule. So if I expand that, I get f of x equals 9x squared plus 6x plus 1. So the derivative equals 18x plus 6. And by chain rule, what you can do is find the derivative of, basically you find the derivative of x squared, right? Where this whole thing is x, or u if you'd like. The derivative of u squared would be 2 times u. In this case, the u is 3x plus 1. Then you have to multiply by the derivative of what's inside the brackets here, which is 3. So f prime of x is actually 6 times 3x plus 1, which is exactly the same as what we got the other way. Okay, so let's do the same thing over here. So if we expand it, we get x to the power of 4 plus 4x squared plus 4. We find the derivative, then it is 4x cubed plus 8x. And if we do the chain rule way, then using the chain rule, the derivative is, let's write that as a 2. So recall, if you got something to the power of 2, the 2 comes down here, and the exponent reduces by 1. And then we have to use chain rule. We have to multiply by the derivative of what's inside the brackets. The derivative of x squared plus 2 is 2x. So the whole thing is 4x times x plus 2. Okay, next we're going to do some more examples. This is the example we talked about a bit earlier that we started. So remember, h of x equals x squared plus 3 to the power of half. So when we find the derivative, okay, we treat this like one thing. So the derivative of something to the power of half is half times that function to the power of negative half times the derivative of the function inside the function. So the derivative of that is 2x. And we simplify, half times 2x is x. And this is 1 over root x squared plus 3. Okay, so remember, k of x equals 2 times 3x plus 1 to the power of negative 1. So the derivative is, we multiply that, so it's going to be negative 2 times 3x plus 1, reduce the exponent by 1, times the derivative of what's inside the brackets is 3. So this is negative 2 times 3 is negative 6. This is, I can write this in the denominator as 3x plus 1 squared. Okay, our next example, we have e. Remember, the derivative of e is e to the x is just e to the x. So when we find the derivative, that's going to be e to the power of 2x plus 1 times the derivative of what's here inside the function, which is 2. So it's just 2e to the 2x plus 1. Okay, in the next example, let's rewrite this as y equals e to the 2x minus x to the power of half. Then we have dy dx equals half times e to the 2x minus x. Reduce the exponent by 1. Then chain rule says we multiply by the derivative of what's inside the brackets. Now the derivative of e to the 2x is 2e to the 2x. And the derivative of that is negative 1. So maybe we could simplify a bit by writing this as this in the denominator. So we can write 2e to the 2x minus 1 over 2 times, actually this is square root, so let's write this as a root. E to the 2x minus x, so we can write it like that. Okay, in our next example, we have y equals ln x squared. And there's two ways we can do this, so maybe we'll do it two different ways and see if we get the same answer. dy dx equals, now ln x is 1 over x, so in this case we're going to have 1 over x squared, that's the derivative of ln, multiplied by the derivative was inside the brackets, which is 2x. So you get just 2 over x. Another way you can do it is use a log rule first, so you can bring that 2 down and you have 2 ln x, and then you find the derivative equals 2 over x. So this one here is going to be much simpler if we use some log rules first. Okay, so we can split this into ln x squared plus ln root 2x minus 1. And next you can use another log rule and say this is 2 ln x. And this is to the power of half, right? It's square root, so we can write this as half ln 2x minus 1. And then the derivative is quite simple. This is 2 over x plus half times 1 over 2x minus 1. That's the derivative of ln. Chain rule says we have to multiply by 2, so this 2 and this half cancel. And we have 2 over x plus 1 over 2x minus 1. Okay, next example. Derivative of sine is, cosine is sine, or negative sine. So we're going to have negative sine x squared times the derivative of what's inside the brackets, which is 2x. So it is just negative 2x sine x squared. Okay, in the next example, we have y equals sine x squared, which is sometimes a bit confusing the way that you write sine squared, but let's rewrite it like this to make it crystal clear. This is sine x squared, so the function is, it's like the whole thing is squared, so when you do the derivative, this thing comes out front, the exponent reduces by 1, so we just have sine x to the power of 1, multiplied by the derivative of what's inside the brackets, which is cosine x. And you could also, if you want to, rewrite this because this is an identity. This is equal to sine 2x, right? So that's kind of interesting. The derivative of sine squared x equals sine 2x. Okay, next we have actually a function inside of a function inside of a function. So we're going to use chain rule twice. The outermost function is ln, so the derivative of that is 1 over whatever is inside the ln brackets times the derivative of that, which is negative sine, times the derivative of what's inside the brackets here, which is 2 pi. So the whole thing is going to be negative 2 pi sine 2 pi x over cosine 2 pi x, and you can even simplify that more because you might recognize that sine divided by cosine is tangent. So this is actually equal to 2 pi tan 2 pi x.